Okay, for historical reasons, it is important to now show you this figure because this was a figure which was originally shown, which was originally discussed at the NeurIPS 2015 workshop for deep learning, and that was essentially the first workshop for deep learning. And this was like a pretty big deal, and it's not very well known outside the insider circles, but it's pretty cool to have. So this is an alternative to backpropagation, and it essentially summarizes whatever we have discussed. So there are two kinds of connections between a neuron I and a neuron J. So you can see that this type of network is having a bottom-up connection, which is like Wij, and then so this is like bottom-up network, and this is like a top-down network. And essentially, like the top-down network consists of weights in the opposite direction, Wji and Wij. So so here Wij and Wji are not equal. They are like separate weights which are learned during using the process which I told you earlier. Now I'm going to talk about like how does it actually work. So let's say that this is like the output neuron and this is like an input neuron. So this is like the last layer and this is the second last layer of the network. So you first feed in like your xi and like whatever activity you have, and then finally like you get an output y. And then what happens is that you have a target t and you compute like the difference between those, and what it gives you is basically the delta y activity difference. And then you feed in like the total input, which is yk plus delta yk, into like a top-down neural network which tries to reconstruct like the input activity which was fed in to the neural network. Okay, so this is like the input activity and it's essentially equal to like xi plus epsilon, and you're trying to reconstruct like xi using this top-down neural network. So this total input is the input which you're trying to construct using a top-down neural network, and then the final yi which you compute, like this final delta yi, is actually the change is actually the gradient signal at this particular neuron. So this delta yi is like the gradient signal which is at this particular neuron I. And let's say that this neuron I is connected to like a neuron J, like it's connected to like these three neurons, J1, J2, J3. So then essentially like, and let's say this output of the neuron is yj1, yj2, yj3, and you can essentially like compute like the output of, you can compute like the weight change which has to be made on this connection as just multiplying the output delta yi by yji. And this is essentially the change in the weight you need to make. And that's what like this is saying, that this can be repeated for as many earlier layers. The learning route is equivalent to modifying each incoming weight in proportion to the product of the presynaptic activity. So product of like, so yji in this case is the product of the like this input activity which was coming in, along with like the change in the activity which you got after piping back the error signal from the top-down neural network. And this does not involve like any sort of like chain rule or any sort of computation like that. And the key point is that after like you have done this, so you have like a error signal at this point which is like del I, and you need to so like you have the so let's say this is layer L, so you L plus 1, and this is like layer L. So you have like a error signal at this point which is like del L plus 1, and you need like a way to calculate like the gradient, the error signal at these locations, which is del L. So how do you calculate like the del L plus 1 from del L? And that remains like a key question, and we can easily solve that. And for that you can look at this equation, which is like pretty interesting. So I will talk about that in the next video.